Hey guys, we are going to work on lesson 12, page 58, derivatives of transcendental functions. So what are transcendental functions? Well, they're the functions that have the variables in the exponent, like e to the x, 5 to the x, or there are logarithmic functions. So logarithmic and exponential functions are our transcendental functions. And taking the derivatives of these are actually pretty easy to do. So what I'm going to do is I'm going to go ahead and give you the rules. You do have them in your manual, but I'm going to go through each one, and I'm going to use u. So d du, so the derivative of u of an ln function, so ln of u, is equal to 1 over u du. So an example of that is, let's say we need to take the derivative, find the derivative of ln of 3x. The derivative of ln of 3x is 1 over 3x times 3. So this would be u, 1 over u, 1 over u, du. So the derivative of u, which is 3. So there's the derivative of ln. Next, let's take a look at the derivative, d du, of e to the x, or e to the u. So base e with any power. d du of e to the u is actually e to the u du. So the derivative of e is e. So the derivative of e to a power is e to the power times the derivative of the power. So another example, let's say we're taking the derivative of e to the 3x. The derivative of e to the 3x is e to the 3x times 3. E to the u, du, the derivative of u, where u represents basically any expression that we can put in there. And u could now be anything. U could be, in this case, it's just 3x, but it could be x squared plus 1. It could be a trig function. It could be a chain rule. It could be any of the rules that we have already encountered. Okay. So now I can't move that. That don't want to stay. They don't want to move. All right, let's just leave that there. All right, and the last one is a to the u. A to the u is when your base is a number, where a is a number. Okay, a is a number, and like for example, like 5 to the x. The derivative of a to the u is equal to a to the u equal to come on equal to a to the u ln a du. A to the u ln a du. So let's say we needed to find the derivative of 5 to the x squared. The derivative of 5 to the x squared would be 5 to the x squared ln a times ln 5 times 2x. So a to the u ln of a ln of 5 du, the derivative of that guy, so 2x. So this is a, this is u, a to the u, ln a, du. So now let's take a look at some problems from the manual. Those are the rules, that's it. So we're going to just do problems from the manual. We have all the other types of derivatives we have done, so we've just added these 3, 1, 2, 3 to that list. All right, now let's go to the manual. Okay, taking a look at the manual, number 3 on page 58 right here. This is an ln of u, and we're taking the derivative. So the derivative of ln u is 1 over u du. So 6x minus 5. That's the derivative for number 3, and then we would just put this in the numerator and that in the denominator. All right. Same thing for here, ln u, and we are taking the derivative, so y prime is 1 over u times du. The derivative of square root of x is 1 over 2 square root of x. So then you would simplify that to be 1 over 2x, because square root of x times square root of x is going to be x. So that's going to be 1 over 2x. Now we have different types. Here we need to identify them. We have 5 forms now. We have the power chain, we have a product, we have a quotient, we have a trig derivative. What else do we have? We have product, we have quotient, we have power chain or implicit. And now we have transcendental. Transcendental. All right. So this right here, number 5, the big question is a product rule. Because you could see a function times another function. So you will do 1 d2 plus 2 d1. So y prime is equal to 1 d2 plus 2, which is ln x, d1, which is 2x. Notice how when I did the derivative of ln x, it's 1 over x dx, and the derivative of x is 1. So 1 over u, 1 over x, times the derivative of x, which is 1. And then simplify, you can simplify right there. Big rule right here, that's a quotient rule. So I'd like you to try that one on your own. Another quotient rule. And looks like this is a power chain rule, where we have to do d outer and then d stuff, where ln x is our stuff. So this is a power chain rule. I'm going to call it PC, power chain rule. So I want you to try 6, 7, and 8 on your own. Taking a look now at 9 through 12, looks like right here we have another power chain rule. Power chain. Looks like here we have trig. And the reason why we have trig is because we're doing cosine of ln x, where ln x is the angle. So when we do the derivative, it is a trig, so it's d trig d angle. So derivative of cosine is negative sine. So d trig times d angle. So derivative of cosine is negative sine of the angle times the derivative of the angle, which is 1 over x. As opposed to this one, which is a transcendental. This is just a transcendental, or you can call it an ln. It's just a regular ln u question. So the derivative of ln u is 1 over u du. So y prime is equal to 1 over u du. 1 over u, so 1 over cosine of x, times derivative of cosine of x. And we can simplify that to be negative tangent of x. This is also an ln, but you have the u is also ln. Okay, so this one's kind of interesting. So this is, we'll call this, that's u. That's u. So y prime is equal to 1 over u, so 1 over ln x, times the derivative of ln x. So 1 over u times the derivative of u. 1 over u times the derivative of u. Well, the derivative of ln x is also 1 over x. So 1 over u times derivative of u. Our log rules from pre-calc will make our lives much easier when we're doing ln problems. So let's quickly review these log rules from pre-calculus. The log of a product is equal to the sum of the logs. So ln of a times b is equal to ln of a plus ln of b. The log of a quotient is equal to the difference of the logs. So ln of a minus ln of b is the same as ln of a over b. And the log of a powered number is the same as the power multiplied by the log, or the ln of the base. So you want to try and use these log rules to make your life a little bit easier. The direct approach would be doing 1 over u du right away. And when we do 1 over u, it's no problem. We have 1 over x sine of x. But when we go to do du, when we go to do the derivative of this, we have to do a quotient rule. And that's, it's not bad, you can do it, but it's just going to be messy, where it's much faster to rewrite the problem as ln of x plus ln of sine of x using the log rules. And we did that because it is ln of a product. And then doing sum and difference by taking the derivative of each piece. So ln of x is 1 over x plus ln of sine of x is 1 over sine of x times cosine of x, 1 over u du. And then it's just a matter of writing this as 1 over x plus cotan of x. For number 14, we'll use the log rules to clean that up. And it looks like we have something to the 1/2, so it looks like it's this log rule. It looks like it's ln of x squared plus 2x to the 1/2. So we can use that this log rule right here to rewrite it as 1/2 ln of x squared plus 2x. That's basically y rewritten using the log rules. Now we have a constant coefficient of 1/2. So y prime is equal to 1/2 times, let's take the derivative of ln of this guy. So ln of u is 1 over u du. 1 over u du. Okay, and then it's just a matter of multiplying across. To simplify, it looks like we could take out a 2 from here, so cancel with this 2. But if you multiply across and simplify it from there, you'll see that your answer, your final answer, if you are able to do that correctly, is x plus 1 over x squared plus 2x for that one. All right, and it's much faster to use your log rules. So if I can just use log rules to rewrite number 15, I'd be using the quotient. I'd be using the quotient log rule to rewrite this as y equals ln of x squared minus ln of 3x minus 2. I'd be doing 1 over u du here and 1 over u du there. I would be rewriting this one with a couple log rules on number 16. I'd be using this log rule and this log rule. So I'm going to rewrite 15 and 16, and I want you to finish them up. So let's rewrite this together as 1/2 multiplied by ln of x squared minus 1, put that in parentheses, minus ln of x squared plus 1. So we did the power to coefficient, because this is all raised to the 1/2 power, so that came to the front as b right here. And then we took this quotient and separated it as a log of the difference of the logs. So ln of x squared minus 1 minus ln of x squared plus 1, and 1/2 is multiplying to all of this. Now when I derive, I've got my constant coefficient of 1/2, and I'm going to do 1 over u du minus 1 over u du. So I want you to try those on your own, and you'll check your answers tomorrow. Since we have implicit differentiation in our tool belt, we're going to see implicit on 17 and 18. I'm going to do 17 with you, and I'd like you to do 18 on your own. 17, 2x minus 3 times 1 over y dy dx plus 2y dy dx equal to 0. Now let's go through this. Took the derivative of x squared to be 2x. Took out my constant coefficient of 3. I'm doing the derivative of ln y. 1 over y multiplied by the derivative of y with respect to x. 1 over u du. 1 over y times dy dx. Because we're deriving implicitly. How do we know we're deriving implicitly? Because it's not in y equals format. Since it's not in y equals format, it is implicitly stated, and we have to use implicit differentiation. Continuing on, y squared 2y dy dx is equal to 0, and from here you should be able to finish it by isolating dy dx. So I'd like you to finish up 17 and 18.